Okay, so here we go. Here we see rectangles for fractions. I like using rectangles better anyways than circles because circles can be difficult, especially when we're talking about odd numbers. Rectangles are a little bit easier to deal with, okay? So we can look at this as like maybe a rectangular pizza or even like a brownie pan when you cut up the brownies into pieces, okay? So here we're going to talk about equivalent fractions, okay? So the shaded unit of fractions have been decomposed into smaller units. Express the equivalent fractions in the number sentence using multiplication. The first one's been done for you. Okay. So decomposed, right? Do you remember what that means? Decompose means to break down, okay? So if I zoom in on this first guy here, let's do that. I'm going to zoom in like that. All right. The decomposition here is the dotted line. You see how that's dotted? All right. So this fraction here was 1/2. You see how half of this whole thing is shaded in? And you can see the solid line down. So it originally was 1/2, okay? Well, what we did here was then cut it again, okay? Do you see that? We decomposed it to be smaller pieces, okay? So we broke it down into smaller pieces. That's what that decompose means, okay? I don't know if you can see that. There it is, okay? All right, so what they did was kind of drew this line here. So if you cut this line again into smaller pieces, now all of a sudden we've got 4 pieces. You see that? 1, 2, 3, 4. And that's where this 4 comes from. But you notice the shaded area didn't change at all, not even a little bit. It's the same exact thing. Now, when I talked to you about 1/2 is equal to 2/4, do you remember this little piece that I showed you before? Well, the same thing is being represented right here, okay? So what they did here was you took your 1/2 and then they multiplied both the numerator and the denominator by 2, all right? And you'll end up with 2/4. See that? They chose 2 because we just cut it at half again to make two pieces. So 2 times 1 is 2. 2 times 2 is 4, okay? So you end up with 2/4. And I know that's equal to 2/2 because if the whole thing is 4 pieces and I have 2 of them, well, 2 is half of 4, so I must have half. All right. Now, I know that might have been a mouthful or a lot to think about. Let's practice it and talk. Teachers, I feel like you're going to be doing a lot of pausing here and drawing on your whiteboard as well, okay? So I'm going to zoom back out and move over to the next one. This is B. All right. So the first thing that we have to look at in B is kind of block out these dotted lines here, okay? You see those dotted lines? Yeah, I do too. All right, so I see the dotted lines, and I'm just trying to say, all right, I don't see those dotted lines right now. So let's look just at this solid line. See that solid line? Right? If I look at that, how many pieces on either side of the solid line? We see that there's 2 pieces, right? And then the whole side is shaded in as 1. So there's 1/2 again, okay? Now here comes the decomposition. Let's just take a look. They put 2 cuts in this way. When we talk about 2 cuts, how many pieces is 2 cuts going to give you? It's going to give you 3, isn't it? Let me give you an example. If I have a board and I want to make this, or a candy bar we'll say, and I want to make 3 pieces out of this little candy bar, all right? I need to cut it twice. 1, 2. See, now I've got 3 pieces? Yeah, okay? So what they did here is this. They had this rectangle like that, okay? They had this solid line to begin with, and this whole side was shaded, okay? Follow me? I'm going to use a different color pen. Then they decided to cut it twice, this way. Let me just get this guy working. 1, 2, 1 cut, 2 cuts. Good. See how they got 3 pieces on either side now, which is 6 total? So 2 cuts is going to give me 3 pieces. So they multiplied this by 3. So I'm going to have 1/2 times 3 up top and times 3 at the bottom. And that's going to give me 3. 2 times 3 is 6. All right, do you see how now when I decomposed it, I got 6 pieces, 1, 2, 3, 4, 5, 6. That's where my denominator is now. And 3 of those are still shaded. That's the top right there. Good. All right, it's really tough here recording this and not seeing the reactions on kids' faces. So please, if we need to pause and explain this further, please do. All right, let's move down here. Good. Looks like all of these are halves, okay? So we started off here, 1/2 of it shaded. Perfect, okay. Then I ended up with, try this one a little differently. He decomposed it here. You see I got 3 cuts? Well, how many pieces does it make now? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So we ended up with 8. And how many are shaded? 4/8, right? Just like that. So we went from 1/2 to 4/8, okay? So what did I need to multiply my 1/2 by to get 4? Okay? What did I need to multiply here? Both the top and the bottom by. All right? 1 times blank gives me 4. That's right, it's 4. 2 times 4 gives me 8. See, I multiplied both the numerator and denominator by the same number. Okay? And I get equivalent fractions. 1/2 is equal to 4/8. Same amount, same thing. 4 is half of 8, I'm good. Okay? Let's move over here. Great. So we start off with 1/2 as usual, so 1/2. But what do we end up with? Let's talk about that. So now that we decomposed it, they cut it again this way. All right, 4 cuts. 4 cuts gives me 1, 2, 3, 4, 5 pieces this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So we cut that into tenths. How many are shaded? 1, 2, 3, 4, 5. So 5/10. See how 5 is half of 10? That's equal to 1/2. Just really small, a lot smaller pieces this time. So we took 1/2, decomposed it by multiplying it into smaller pieces, right? How many pieces, what did we multiply both the top and the bottom line? 1 times 5 equals 5, and 2 times 5 equals 10. So we multiply both the top numerator and denominator by 5 to get 10. Okay? All right, now as usual, we want to look back and take a look at our work and see how that's done, see how it's good, all right? Now, if I just doing some whiteboard work here, teachers, good pause here to do another fraction might be a good idea, all right? But I'm going to keep moving. Okay, here, we're going to actually, you can see here that we're going to decompose some. You might see some dark lines here. That's just me coloring it with pencil because there was a space there with the copying. Decompose the shaded fraction into smaller units using the area models. Express the equivalent fractions in a number sentence using multiplication. Okay. So here we have to come up with our own way. So first of all, I want to write down the fraction that I see. All right? What fraction do you see here? Out of this whole rectangle here, we're just going to focus in on that guy right there. Okay, what's this fraction? Right. If you said this fraction is 1/4, I'd say you're right. Okay. Now what we're going to do is decide how many rows we're going to cut this into. How many rows do we want? Okay. So, and then we're going to end up with an equivalent fraction because we're not going to shade any more in. So how many rows do we want to multiply by? All right. Now I could just give you one cut this way, which give me 2 rows. I could do 2 cuts, okay? All that kind of fun stuff. All right. Let's just do 1 for now. I'm going to cut it this way. Right down the middle. Right? Good. Now you see how I cut this down the middle. So how many rows do I have now? That's 2 rows, correct? That's right. So what I did here is multiply both the top and the bottom by 2, right? Because this 1 now turned into 2 shaded areas, right? And the denominator, the 4, which was these 4 things, now it's 1, 2, 3, 4, 5, 6, 7, 8. It's 2 8s. Those are equal to each other. Okay? Make sense? Hope so. It's kind of hard without seeing the reactions of you guys. Let's try this one. All right. First thing we need to do is find out our fraction. What fraction do we see right here? All right, so I'm going to count the total pieces. 1, 2, 3, 4, 5. Okay, so this is cut into fifths. So that's my denominator. And I see 1 shaded. So it's 1/5. No doubt about it. Okay? Now we're going to try to make a equivalent fraction by multiplying that 1/5 by both the numerator and denominator by a number. So we have to figure out how many rows we want to make. All right. I'm going to decide here for us because I can't really call on anybody being here in virtual land. I'm going to make 3 rows. So that means I need to make 2 cuts this way. So 1, 2, 3 rows. So there's 1 cut this way and then another cut this way. So I made 3 rows. But when I made those 3 rows, I cut all those pieces into smaller pieces. Right? Didn't change my shaded area at all. So 1, 2, 3 rows. So there's my 3 and my 3. So I'm going to multiply both the numerator and the denominator by 3. So 1 times 3 is 3. To see how now I've got 3 shaded areas? 3 shaded spots? Yeah. Now my everything, what's my whole? Okay, so 5 times 3 is 15. All right, see this 3 and that 5 makes 15 squares. But these are equivalent to each other. They're the same. 1/5 is equal to 3/15. Because I multiplied both the numerator and denominator by the same number, I get equivalent fractions. Okay? All right. Let's move on to the next one. And again, please read your classrooms and make adjustments as necessary. All right. What's the fraction? Okay, I'm going to write down my little fraction bar here. I counted 6. All these spaces are cut into 6. I know a lot of kids sometimes want to count just the unshaded area and make that the denominator. That's not right. You got to count all the spaces, even the shaded one. 1, 2, 3, 4, 5, 6. Good. Then the numerator is just a shaded area here, so it's 1/6. Okay? Now, I want to cut this into smaller pieces. So we're going to decompose it into smaller pieces. How about this time we cut it 4 rows? We make 4 rows going this way, okay? So if I want to make 4 rows, first I'm going to cut it down the middle and then cut each of those in half, right? Do you see how I ended up with 4 rows? So that means I just multiplied this by 4. And look how tiny my pieces are. So that means my denominator is going to be really big. Okay, so let's try that. I took my 1/6 and I multiplied it by 4. See the 4 rows? Good. Nice. Now I ended up with how many shaded parts? 4. 1 times 4 is 4. Good. And then how many parts total? All right, that's 6 times 4. That's 24. So if I count all these squares, I'm going to end up with 24. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Pretty cool. So we know now that 1/6 is equal to 4/24. Okay? 4/24 is a mouthful. All right, finally over here on this one is D. Let's find the area here, okay? Teachers may want to pause and see if they can do this on their own. All right, so let's start off with counting the total amount. 1, 2, 3, 4, 5, 6, 7. That's 7 sevenths, 1 shaded. What are we going to cut this into? All right, let's cut it into, let's do halves again. Keep it simple. Let's cut this in half. Good. So we're going to get 2 rows. 1, 2 rows. So I took my 1/7, I multiplied both the numerator and denominator by 2, right? So now I've got 14 pieces and 2 are shaded in. So I just doubled it, you see that? 1/7 is equal to 2/14. Cool, all right. So let's take a look here. What happened to the size of the fractional units when you decompose the fraction? So the size of the fractional units. Fractional units are like the smallest piece, okay? Or how many pieces, what the fractional unit was. It was sixths and now it's 24ths. So what happened to the size of it, okay? The size of the fractional units got smaller. Now, it might seem weird, but if I look here, you would think, well, 14 is bigger than 7. You're right. But when I'm talking about my fractional unit being 14ths as opposed to 7ths, you can see when I decompose, these get really small. Could you imagine if I put like 6 more lines in here? We'd have these teeny tiny little pieces, all right? So the size of the fractional units got smaller when we decomposed them, got them to smaller units, okay? What happened to the number of units in the whole when you decompose the fraction? Okay, the number of units in the whole got bigger, right? So you see how we went from 7 units then to 14? Here I went from 6 units to 24. So the number of units got larger. The total number of units, total number of units, I'm going to use a special word here, increased, right? How about that word? Increased. It means got bigger, right? Increased, period. Cool, right? Total number of units increased. All right, now finally here. Okay, now we get to draw a little bit. That's what I love about fractions. You get to kind of draw and figure this out, okay? Draw 3 different area models to represent 1/3 by shading, okay? So we got to draw 3 units of 1/3. So we're going to do 3 of the same thing, okay? We're going to decompose the fraction A into sixths, B into ninths, and C into 12ths. I can do that, and I'm going to show you how it's done. We're going to use multiplication to show how each fraction is equivalent to 1/3. Okay, so I'll show you here, okay? First, let's draw our rectangles, and let's try to draw them the same exact size all the way down, okay? Just freehand. There's one rectangle. For B, let's draw another rectangle just about the same size. Okay, you can do your best with that. And then C, I'm going to draw 3 rectangles in those little areas, okay? Cool. See if I can zoom out so you can see that here. I'm going to raise this up a little bit. Do you see how I made 3 rectangles up about the same size? I'm just doing it freehand here, okay? Now what I want to do is make all of these into 1/3, okay? So 1/3, I'm going to cut them down this way. Now, how many cuts do I need to make this into thirds? Shout it out if you know it. That's right, I need to cut it twice. So I need to kind of gauge here where it's going to be. I'm going to cut down right about here, and I think right about there, right? So I got 1, 2, 3. See, 2 cuts down gave me 3 pieces, and I'm going to shade one of them in like that, okay? Perfect. Now I want to do the same thing here. I need to cut this into 3 equal sections, so it's 2 cuts. So right about here and here, we'll say. See how I just do a little bit of tick mark on top of them? I'm happy with that. I'm just going to bring these together down there like that. Good. Then I'm going to shade that guy in. See, I'm just using the side of my pencil and just kind of dragging it a little bit. Yep. Then finally, the last one, I'm going to do the same exact thing, thirds. Okay? And I'm going to shade that 1/3 in just like that, okay? Good. All right, so what we want to do up top is we want to take this 1/3, right? See how that's 1/3? 1 shaded in out of 3, so 1 out of 3. and I want to change it into sixths, okay? So what do I multiply 3 by to get 6? Okay? If you said you're going to multiply it by 2 to get 6, that's correct. So what if I said I'm going to multiply this 3 by 2 to get sixths? That's correct. So I need to make 2 rows here. I need to cut it this way once to get 2 rows, right? See how I get 2? So that means if I did that to the denominator, it has to happen to the numerator too, because you see the numerator then split into 2 pieces. So that ends up with 2 sixths. See that? Yeah, it's pretty cool. So same size, same amount, just now smaller pieces, okay? Because now from thirds to sixths. So the bigger that denominator gets, the teeny tiny piece becomes, okay? All right, here's this one. And this one we have to do to ninths. So we're gonna start off with our 1/3, and we have to get all the way over here to ninths, okay? So what do I multiply 3 by to get 9? Right, if you said 3, that's right. So I gotta take my 1/3, and I need to multiply by 3 to get 9, right? 3 times 3 is 9. So that means I need to make 3 rows. So I need to make a cut this way here and this way. So now I got 3 rows going this way. And as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. It made ninths. And now this shaded area is now 3, because 1 times 3 is equal to 3 ninths. See the equivalent fractions? And finally, I've got 1/3 again, and this time it's twelfths. I need to make sure that I change this into twelfths. So I'm going to ask myself, what times 3 is going to give me 12? That's right. I knew you knew it. It's 4. So I need to get 4 rows down here. So I need to go 1 down the middle. 3 cuts going to give me 1 cut here and then 1 cut there. And end up with 1, 2, 3, 4 rows. Perfect. 3 times 4 is 12. And I must do the same thing with the top. See how my shaded area was split into 4 pieces? 4. So this turns into 4 twelfths. Okay? Well, I hope this helped you out with a little bit of equivalent fractions using area models and using multiplication, okay? We're going to do more of this tomorrow. And it's super important that you are engaged, that you're paying attention, you're giving maximum effort the whole time, okay? Great work today, kids. We'll see you tomorrow for math class.